triangle and it is not marked as being a right triangle, and that's what we're trying to figure out given the side lengths if it really is. And so this is really using the converse of the Pythagorean theorem, which says if you've got these different side lengths of 2 and 6 and 3 times the square root of 5, if it works by plugging it into the Pythagorean theorem and those two sides on both, or the both sides of the equation are really the same, then it must be a right triangle. So we're going to plug that in, and you've really got to determine what is your c squared, or what's your c value, what's your hypotenuse. Don't always just trust by looking at it. Some might look at this and say, well, I think 6 is, no, I think 3 times the square root of 5 is. You might have to do a little calculator work. When you take the square root of 5 and multiply it by 3, you'll find out that it's about 6.7 or something like the longest side. So you got to make sure you recognize that first. So that's the side that you're choosing to be your hypotenuse, if it's really going to be your hypotenuse. Okay, if it is a right triangle, that would be your hypotenuse. And then the other ones you can plug in here. So that's 2, we're going to square it, and then the other leg would be 6 and square it. And really we're trying to determine, I'm writing this down as an equal sign here, but I'll put a little question mark up there saying, is it really equal? That's what we're trying to figure out. Okay, so 2 squared is 4, 6 squared is 36. Is that going to be equal to this when I square it? Well, that ends up being 3 squared is 9. Square root of 5 squared is 5. And so again, we're asking the question, are those the same? Well, 9 times 5 is 45. 4 plus 36 is 40. And no, those two sides are not equal, and therefore we can look up here and say this is not a right triangle, because if it was, then a squared plus b squared equals c squared would work.